So I will talk about the quest in a few minutes. We'll let a couple of the stragglers come in before we make announcements there. But we'll jump in by looking at our calendar as usual. So today we talk about graphing parabolas. So far this semester, everything that we have graphed has been what kind of a graph? Linear, straight line. And so today we're going to graph curvy things, parabolas they're called. You can see here it says day 1 of graphing parabolas, and it's going to be a little while before we come back to it, but right down there we have a second day of graphing parabolas once we know some more stuff. Okay, so that's the plan. Any questions on the calendar? Okay, so at the top of page 146, let's go to the daily summary. Alex? Thank you. Marcy, number 1. Thank you. Lucas, number 2.
Below the graphs of y1 4x squared minus 4, y2 x squared plus 4x plus 16, y3 x squared.
Okay, let's pause right there. So first we're going to highlight this thing up here, y equals ax squared plus bx plus c. We're going to see that equation a bunch of times in the next few classes. I think we mentioned it last class, and so let's talk about it again here. The numbers, the a, the b, and the c represent numbers, constants. They're different than the x and the y, which represent the variables that we can plot points and talk about solutions to the equation. And so it's going to be really important for us to be able to take an equation like that guy and identify the values of a, b, and c. And so I'm just going to write here a equals, b equals, and c equals. So a apparently is the number that's touching the x squared. What is the number touching the x squared in this example? Is a -1. And so we're going to put a -1 right there. So a is always the number touching the x squared. And the next thing I see here is this b, which is the number that's touching the x. What's the number touching the x? It's +10. I'm going to put a plus sign. You can just write 10, but I want to make sure we're always including the signs. And then finally, c is the number sitting at the, usually at the end, but the important thing is it doesn't have an x attached to it. So how much is the value of c in this example? Is the -25. It's not just 25, but it's -25. Any questions on identifying the a, the b, and the c? Okay, so that'll be important to us, I think, next class. For right now, let's keep going here. Jeremy, Hughes? Okay, so we haven't done this in a while, but finding y-intercepts is a process we did way back when. What do we do to find the y-intercepts of anything? 0 for what? 0 for the y? 0 for the x. Which one is it? 0 for the x. Remember, it was to find an intercept, you let the other variable be 0. So to find the y-intercept, we're going to let x equal 0. So let's try that for the first equation, y1. So we're going to change all the x's into zeros. So that becomes 4 times 0 squared minus 4. Everybody see what we're doing? And then we crunch that through. How much is it? -4. And so that means that we now have a point. It has an x and it has a y. How much is the x? 0. That's how we figured it out. And how much is the y? -4. That's what we calculated. Okay. So the y-intercept there is 0, -4. With your neighbors, go ahead and find the y-intercept for the other 2 equations. They're called y2 and y3. Okay, let's get our other intercepts up here. For y2, what was the y-intercept? 0, 60. And then for y3, 0, -25. Everybody okay with that? Just plug 0 in for the x's. And you might have already discovered a shortcut here. How can you look at an equation like these and immediately tell what the y-intercept is? It's the c, right? It's that guy without the x. Okay, fair enough. So 0, 60, 0, -4, 0, -25 apparently are the y-intercepts of these three guys. So that should tell us which one is which. So 0, -4, what color up on my board here? What color goes through this point? 0, -4. Wait a second here. Oh yeah, there it is. I was having trouble telling where the y-axis was. Okay, so there's the y-axis. So which color is the graph that goes through the point 0, -4? Is blue, right? 0, -4 is this point down here at the bottom of the blue guy. All right, so apparently y1 is that blue one over there. So let's label this one. This is y1. Next one is 0, 60. What color goes through 0, 60? Is green. It's the dashed one. So green apparently is y2. And then process of elimination, but let's just check anyway. 0, -25. We buy that. Looks like the reddish thing is going through something around 0, -25. Okay, so that means this reddish thing must be y3. Fair? Okay. So each of these graphs right here is called a parabola, and they are quite different from the linear line things that we've been drawing all semester. You can see they're curvy. Sometimes they go down and then back up, or the other way around, like the red one goes up and then comes back down. And so we're going to talk about some of the characteristics of these graphs, and then we'll graph them. Let's go to 3. Where are we? Will? Parabolas. Good. Ramses? Okay, let's pause there. All right, so we've got how many happy parabolas in this example? 2 of them. And then how many sad ones? 1. And I'm telling you that the thing that yeah, just a, just the value of a. So remember, the value of a is the number that's touching the x squared. So how much is a for this first guy? 4. And then for the second guy? 1. And then for the third guy, we did it already, but I'll write it here. Whoops. How much is a for this last guy? Is -1. And the 2 happy parabolas are y1 and y2, and the values of a were 4 and 1. And the sad parabola was this y3, and the value was -1. Can you tell what makes a parabola happy or sad, just looking at the a? It's the positive and the negative, right? If a is positive, then the parabola is happy. If a is negative, the parabola is sad. Ramses, keep going with if. Sad. Okay, so up or down, completely determined by whether a is positive or negative. Okay, part B talks about x-intercepts. Let's look at this picture. How many x-intercepts does the blue parabola have? X-intercepts for the blue parabola has 2. 2 places where the blue parabola crosses the x-axis. Yeah? How about the red parabola? How many x-intercepts? Looks like just the one, like it just barely touches the x-axis and then runs away. Green, how many x-intercepts? 0. So it turns out that those are all the possibilities, and it says it here. Our parabolas have 0, 1, or 2 x-intercepts. There's not possible for a parabola to have 3 or 4 or 5. Those are the only choices, 0, 1, or 2. Yeah, because you think about it, parabolas look like either happy faces or sad faces, and you can move them around and you can make them wider or narrower or whatever, but you never get something that goes down and then up and then down again. So you'll never have the opportunity for more than 2 x-intercepts. Okay, and so how do we find x-intercepts for these graphs or for any graphs? Well, it's the same thing that we did before earlier this semester. We set y equal to 0 and solve for x. So we're going to talk about doing that. That's a little bit more complicated and sometimes involves factoring. Okay, let's move to C, Tyler. Okay, so looking at the blue parabola, does it have a highest point or a lowest point? There's a lowest one, right? It doesn't have any highest points. It goes up forever. So that lowest point right there, according to what Tyler just read, is called the vertex of the parabola. How about red? Does red have a highest point or a lowest point? Red has a highest point. Looks like it's right around there. And again, it's called a vertex. So it's just a vocabulary word. And it's one of the things that's important in terms of graphing parabolas. Definitely want to know where the highest or lowest point is. Yeah, I think calling it the middle is a reasonable thing to say. It's a place where the behavior changes. If it was going up until the vertex, like the red, then it starts to go down after the vertex. If it's, yeah, the vertex for the green one is at 7, comma, I don't know, 12, something like that. Okay, more about vertices. Let's keep going here. Consider, okay, so let's go to Savannah for consider.
Consider the parabola closely on our x=1. How could we use the find the location? The average. This will give us the x-coordinate of the vertex. In case of the small parabola as well. X equals 1 plus 1 2 equals 0.
Okay, so look at the two black dots I've drawn up here, the two x-intercepts of the blue curve. Looks like they're about 1 and -1. And it sure seems like this vertex, this bottom point, is halfway between. Yeah? And so if we want to find where that vertex is, well, we can just average the 1 and the -1. How do you average two numbers? Add and divide by 2, which is exactly the calculation that Savannah just read to us. 1 and -1, we add them and we divide by 2, we get 0. That seems quite reasonable that x equals 0 is where that blue vertex is, that bottom point. And to find the y-coordinate, well, you have the equation up here. Y1 is the equation for the blue. We just found that the x-coordinate is 0, so we can plug that 0 in for the x and get the y-coordinate is -4. And so the vertex apparently is at 0, -4. Okay. Yeah, for us to find the vertex at this point, we need to find the two x-intercepts. Then we need to average them to find the x of the vertex. Then we need to plug that guy in to find the y of the vertex. Yeah, so it's a big old process. Very soon, we're going to have a quicker process to find the vertex of a parabola, but not today. Okay, so on the next page, we're going to kind of put everything together and use a 6-step process to graph a parabola. So we're going to sketch this guy right here, y equals -x² plus 4x minus 3. And the steps are mostly written out here. And again, the process is on the next page, which you can look at while you do the activity. But let's go ahead and read through this and do a little bit of graphing. So first of all, I want to know if this is going to be a happy parabola or a sad parabola. Remember, the value of a determines happy or sad. How much is a? -1. Everybody okay grabbing that -1? So the fact that it's negative, does that make this a happy or a sad parabola? Sad. So this is a negative number. So the parabola is sad, right? So we expect it's going to open downwards. Okay, next thing we'll find is the y-intercept. In general, how do we find any y-intercept? X equals 0. And if we let x equal 0 here and here, then all those zeros essentially add to nothing. And what's left over for the y value is -3. And so our y-intercept is 0, -3. Everybody see that? So let's go ahead and plot that point right now. 0, -3. Is that, if I start at the origin, is 0, -3 left or down? Down. Okay, so 0, -3 is right there. That's our first point. Okay, next step is the most complicated step, I would say. We're going to find the x-intercepts. In order to find x-intercepts, remember we're going to let y equal 0. So this value, this y right here, is going to become a 0. And so that equation is just written out right there. Everybody see the first step? 0 for the y. Okay, but now we're going to solve that equation, which is complicated. But last class, we talked about solving complicated equations that look just like that. It's quadratic. And so we're going to use the box in order to factor that equation. So I've done part of it here for you already. In the top left, we put the -x². In the bottom right, we put the -3. What is this 3x squared? Where's that coming from? Multiply that diagonal, right? So it becomes positive 3x². And so now we're going to continue this box idea here. So we're going to list all the factors of 3x². There's very few of them. What are they? 1x and 3x. What's the other? I mean, you could put fractional stuff, but we're going to put integers only. Marcy, -1 and everybody buy it? Those are the only two ways that we can multiply and get positive 3x². And then remember, we're hoping to find something so that the sum is that guy in the middle that we've ignored until now, positive 4x. So if we add in the first row here, 1x plus 3x is exactly the 4x we wanted. The bottom row, we don't need it, but it's a -4x. So what are we putting in the two empty boxes? 1x and 3x. Now, again, it doesn't matter which one you put, but do me a favor and copy what I have here, just so we're all looking at the same thing. Okay, and then we start factoring out. So in the top row, what goes into both? You could say -x. I guess I would say there's two different correct answers to this problem. Well, I would say that there's not a negative in both, so I would just pull out x. And then I would look right up here, and I would say, okay, I know that this guy times that guy is supposed to be -x². So what does it have to be? -x on top. And then I know that this guy times this guy is supposed to be the 3x. So what has to go right up here? Positive 3. And then I know that this times this is supposed to equal that. -x times some unknown thing over here. It's supposed to be -1. There, and then we cross our fingers that that guy times that guy gives me the thing in the box. Does it? It does. Okay, so we've got our factors. So we just have to read them off from the box. So let's write down our two factors here. So -x plus 3 and x minus 1. For certain kinds of factoring, there is a number on the outside, but not all the time. Order does not matter. Okay, the green highlighted equation from up above is supposed to represent this green highlighted thing here, but I'm missing an important piece. I factored the right-hand side. I buy that those are equal. What are we missing? Is equal 0. We got to have that. It was equal to 0 before. It's still equal to 0. And now it's a matter of taking our two factors and setting them each equal to what? 0. So we go 0 equals -x plus 3 and 0 equals x minus 1. And then we solve for x. So how much is x in this first equation? Is it 3 or negative 3? 3. And then the second equation, equals 1. And so that means we now have 2 x-intercepts. We just found that x is 1 and 3. How much are the y's? 0. That's how we started this process, right? We let y equal 0. So those are your x-intercepts. Finding x-intercepts is typically quite a long process, as you just saw. Finding y-intercepts, really quick, but x-intercepts takes a lot longer. Okay, let's go ahead and plot those 2 points on the graph, 1, 0, and 3, 0. And at this point, I bet there are some people that are having a hard time seeing a parabola that hits those 3 points. Anybody having a hard time, or can you guys kind of envision the parabola that's going to hit those 3 points? Yeah, like it seems like if it's going to, like I was maybe expecting, you know, something like that, but now I'm in trouble. Like parabolas don't look like that. We're going to find a little bit more, but can you guys see what this parabola looks like? It doesn't look like what we just drew. It's just a single parabola. Will, what did you say? Does this parabola open up or down? We found this in part A. Opens down. So as soon as I had in my head that I was going to try to hit this point like that, I was done. I couldn't make it do that. So as soon as we say it opens down, I think I heard just a few people say, oh, now I see it. Right? There's a parabola that hits those 3. Something like that. Okay. All right, so we just got a little bit left to do here. We're going to find the vertex. Where is the vertex? What's the x coordinate of the vertex? Vertex is right around there. What's the x coordinate? It's got to be 2. Yeah? We can look at it, and it looks like it's about 2, but is there something you can do with the x-intercepts? We just found 1 and 3. We got to average them, right? That's what Savannah read to us earlier, is that to find the vertex, you just average the x-intercepts. So I'm going to get rid of my blue because that was just an approximation. And then we're going to say, okay, we know that the vertex is just the average of the x-intercepts. So I'm going to write x sub v for the x coordinate of the vertex. And the 2 x-intercepts we found were 1 and 3. So as Ben said, to average 2 numbers, we add them and divide by 2. And so that gives us 4 over 2, or just 2. For this process, finding the average is dependent on how many numbers you have. But for this process, there's going to be 2 x-intercepts, and so we're going to be dividing by 2 every time. Good question. That's the x coordinate, but we also want to find the y coordinate. And if x equals 2, you can find the y because you have this piece of information right up here. X equals 2, we can find the y, yeah? We can plug 2 in for all of those x's up there. So I'll just write this. We found that the x coordinate of the vertex was 2, so we're going to find the y coordinate of the vertex by plugging 2 in for all of those x's. And I go out of my way to put parentheses around any x that I plug in. It helps me avoid any sign mistakes. Okay, so let's do this calculation here. Is this first guy 4 or negative 4? It's -4, right? Because the 2 is the only thing getting squared. That's a +4 with a negative sign sitting in the front. -4 plus 8 minus 3. How much? 1. So that means that the vertex, we've already found the x coordinate. It was 2. Did that by averaging. And the y coordinate we just discovered is 1. So the vertex is at the point 2, 1. Go ahead and plot the point 2, 1 right now. Okay, and before we connect the dots, there's just going to be one more point that I'll ask us to plot. It's always going to be 5 points that I'm going to ask for. We've got 4 of them so far. We know that parabolas are symmetric, right? Like they look the same on the one side of the vertex as the other. And so there's an asymmetry here in that the y-intercept doesn't have its partner drawn on the graph. And so we're going to plot the partner of the y-intercept. So in order to do that, I mean, essentially you're just kind of looking at it and figuring it out, but I'll put this dotted vertical line right through the vertex, which is the middle. I think Ramses, it's at the middle of the parabola. And so can you guys tell me what the coordinates are for -3? Everybody see where Ben came up with that? We're taking this y-intercept and we're just going to flip it over that dotted red line. So I think for -3 makes sense. So I haven't said anything about like where that came from, but if you just like look at the picture and understand the symmetry, you can kind of figure it out. Are there questions on that for -3? Yeah, literally fold the paper. Right. Okay, we've got our 5 points. We connect them with the smooth curve. It's called the parabola. There are a couple of ways that I want to make sure you avoid losing points on the next quest in terms of drawing parabolas. Okay, so here's one way I don't want you to draw the parabola. Parabolas are curvy. If you draw 2 straight lines, then you are missing some fundamental thing about parabolas. Don't do that, okay? The other way that is real common for people to lose points is to do this, which is curvy. So it's looking good, and it hits the 5 points. So what's the problem? It doesn't go through, right? The parabola doesn't just cease to exist because we stopped plotting points, right? The parabola goes forever. And so just make sure that your parabola goes all the way through to the edges of the graph paper. So there's a parabola. Okay, so I think that's everything there. The process again is written out on the next page. So go ahead and jump in on the activities. Each of these problems takes a little bit of time. Oh, before the activities, so let's talk about the quest. Okay, so as per the directions up on the board, you will have the opportunity to earn back up to half of the points that you lost by doing corrections on this quest. So I don't do this very often. In fact, I haven't done this all semester, right? This is the first time. And so the corrections are due start of class on Wednesday. This is a priority for you. So here's what you are allowed to use as you are doing the corrections. You can use any references, any resources on our Moodle page, including our class packets that have been filled in. You are welcome to use anything up on My Math Lab, including the copy of the digital copy of the textbook, practice problems, anything you want on Moodle or My Math Lab. You're also welcome to use anything that you've written down in our notes packets, okay? What you are not allowed to use is other people. So not other people in this classroom, not a peer tutor, not some random person on the internet, and not me. I want you guys individually to figure this out. There are enough resources for you to figure it out, okay? Questions on the rules about the corrections? Okay, so you'll do your corrections on a blank copy of the quest. Everybody has a blank copy of the quest? Okay, so go ahead and jump into the activity and raise a flag if I can help.